Hello, anatomy students. Coach Hicks here, and we're getting into a new unit, the sensory system. Don't let the name fool you. This is actually not another organ system in the body. The senses goes along with the nervous system. You might have noticed in the last unit we talked a little bit about the senses, but we didn't dive in depth, right? We just learned olfactory means to do a smell. In this unit, we're going to get a lot deeper within the senses. So you might have learned as a child, I'm blessing you with my face this time, so here I am. I'm trying to get it out of the way though. Computer software is fun. You might have learned as a child we have 5 senses, seeing, touch, taste, smell, and hearing, right? Actually, the body has 6 senses, and not to think the 6th sense is anything to do with a Bruce Willis movie from the 90s. I see dead people. Okay, you may not get that reference. The 6th one is actually equilibrium or balance. All right, and we're going to look at all 6 of these senses during this unit. We're not going to spend a whole lot of time on each one. Hopefully, you're following along with your notes, and you'll notice your notes look a lot different than some of the ones we've used in the past with slides. Now it's in a docs folder, and it's kind of a summary. I think some of you will really like this. Some of you think this way and you like summarizing things in a nice cohesive little box. Rest assured, the quizzes that follow our notes can all be answered using your student notes. It's not something detail hidden here within our slides presentation or anything like that, okay? So don't get wrapped up in, I got to go back in the slides and look. If you take good notes on that student note sheet, you're good for quizzes, and you're also going to be good for exams, okay? So rest easy there. All right, so the body senses, we just went over them a little bit, and we're going to look at more in depth. All of these senses rely on what we call sensory receptors. In this first little introductory set of the notes, we're just looking at an overview. We're looking at these sensory receptors and also parts of the brain that go hand in hand with the senses. Okay, so sensory receptors enable the body to detect changes to stimuli. Stimuli is anything that we come in contact with, right? So this could be external or internal changes. I feel a spider crawling on my leg. That is a change to external stimuli. My digestive system is feeling a little funny because I ate a burrito earlier and it's not agreeing with me. That internal stimuli is showing there's something wrong with my stomach, okay? These sensory receptors latch on to this stimuli. They're enacted by these stimuli. The senses are linked very closely, as I mentioned before, to the nervous system. The nervous system, our brain primarily, but also our spinal cord and our nerves, they interpret these stimuli. They send signals to our brain sends signals back to these sensory organs or these sensory receptors to make an appropriate response. I need to slap my leg because I want to kill this spider before it bites me, right? That is an appropriate response, unless you're just a really animal lover, and then you want to catch the little guy and move him out back. There's 5 kind of sensory receptors in the body. Try to move. Sorry, my fat head's in the way up here. 5 kind of sensory receptors in the body. One of these is chemoreceptors, and just as the name implies, this has to do with chemicals. I don't know how to get that. There it goes. Sorry, y'all. Chemoreceptors are stimulated by certain chemicals. A good example of this is taste buds in our tongue. Taste buds, as we'll see in this unit, we taste the different chemicals that are in food or drink or anything else you're putting in your mouth. Hopefully, it's edible. But it stimulates these chemoreceptors. Photoreceptors are stimulated by wavelengths, light wavelengths. So what we see out in the world around us. In our eye, there's certain cells called retina rods and cones. We'll look at those a little more in depth and the difference in the two. You might have heard of those before if you've ever been to an eye doctor. But they are turned on. They're in the back part of our eye in this area here. Okay, and they are stimulated by what we take into our eye in the presence of light. So is this light colored? Is it bright? Is it dark? what kind of colors, okay, what hues are coming in and stimulating those rods and cones. Mechanoreceptors are stimulated by touch or by movement. So thinking about, skin, feeling that touch, yeah, that's a mechanoreceptor. Whew, one of those days. It can also be, a good example is our hair cells in our cochlea. That is inside our inner ear, and as we'll learn about that. You don't think about it, but hearing is actually a mechanical touch-stimulated sense, right? We hear wavelengths coming in, not light wavelengths a minute ago, but sound wavelengths moving into our ear, and it causes vibrations on our eardrum and then some other internal organs in our inner ear. That movement is what we perceive as sound. So things can be deep, or things can be high, or things can be loud, or things can be soft. Okay, and it's all dictated by movement, the vibration that we feel on these little hair cells that we'll learn about. We have thermoreceptors, and just as that prefix implies, this is about temperature, right? Stimulated by heat or cold. It's why our hands can be freezing cold out in the elements, or we can get kind of hot if we're sitting in Coach Hicks's room, as some of y'all tells me. It's hot in here. But our skin perceives this temperature, right? And so our brain registers as hot or cold. And then we may take appropriate action to possibly change that or embrace it. We also have pain receptors, this fifth kind of sensory receptors, and this is stimulated by damage. So a pinch, ow, causing pain, stimulating these pain receptors. Think about thermoreceptors and pain receptors can work closely together. These thermoreceptors is going, it's hot, but it reaches a threshold where it's too hot. And then our pain receptors can go, ooh, burning sensation of this tissue. Let me pull my hand away, or let me get out of this burning building. Okay. Pain receptors work hand in hand not only with the skin, they can work hand in hand with mechanoreceptors or photoreceptors, right? I stared at the sun and now it's causing this pain. So pain receptors are sprinkled in with our other sensory receptors. Here's just another chart that what we went over there. I like to show different ways of seeing things. With sight, we have rods and cones. These are photoreceptors. The stimulation of the rods and cones is by light wavelengths. Hearing, and you can read all of this. I just wanted to kind of give you some overview. You see there at the bottom there, mechanoreceptors can also be found in the equilibrium. And we're going to look at the equilibrium or balance next week and how this is a sixth sense. Chemoreceptors, also the olfactory cells in your nose. So it's registering those chemicals that go, ooh, somebody tooted, or cookies, they smell good, because these olfactory cells pick up the chemicals in the air. So once our sensory receptors are stimulated, it needs to give a signal to our brain. Right, so it carries along these sensory neurons. Remember, we have sensory neurons and motor neurons coming out from our brain to all parts of our body. Sensory neurons take the signal from our body or the stimuli that's affecting our body and moves it to our brain. There's specific areas within our brain called sensory cortices or cortex, if it's singular. The sensory cortex refers to all these areas in the brain. You see a great chart here that we're going to look at a little more in depth. Where sensory information is received and then we process it. We feel something crawling our leg and our brain goes, hey, there's something on your leg, you might want to look. Or you smell a scent that smells good, your brain registers as, hey, these smell like cookies. You ate these one time when you were a kid, right? So our brain, the sensory cortex and these sensory cortices register what all our senses are taking in. There's 6 different ones. We're going to look at them here in just a second. So what is the sensory cortex? It's the areas of the brain where sensory information is received and processed, right? In other words, it makes sense of the stimuli that we're feeling or sensing. There's the visual cortex. This is found in the occipital lobe. This deals with vision, no duh. Auditory cortex. This is in the temporal lobe. We see that this deals with hearing, audio. Hopefully you've heard that term before. The olfactory cortex, Dealing with smell, we looked at olfactory a little bit with the olfactory nerve that links to this cortex. The gustatory cortex deals with taste. This is where we register, does this taste sweet, or this tastes bitter. Right? It makes sense of what chemicals we're taking into our tongue, on our tongue. Somatosensory, let me move my fat head here. Somatosensory cortex, this is dealing with touch, pressure, and pain. Soma means body, so somatosensory. And the vestibular cortex has to do with our position and our movement. This is equilibrium, right? It's not just about balance. It's also understanding I am sitting upright, or I am in fetal position down on the floor. We can make sense of our position. It also enables our movement. Think about spinning around a bunch of times when you were a kid and then trying to walk. What happens? You are all out of balance. Your movement is messed up because you messed up actually the inner ear. And the signal that moves from the inner ear to the vestibular cortex, the cortex can't make sense of it now. Okay? This is the first part of our notes. Go ahead and make sure you're filling in your notes correctly using these videos and our slides presentation. Hopefully it'll be easy for you, and hopefully it'll be a nice little compact place that we have, 6-7 pages of notes instead of 50 slides. That's my goal for you.